My name is Joy Ugoyah. I recently graduated from the Department of Petroleum Engineering at University of Port Harcourt. I'm also a machine learning engineer. I have worked with startups to help them develop AI systems and develop their business strategy as a technical advisor and a business strategist. So today I would like to share with you a research I did, a practical application of AI in petroleum production, and the case study is machine learning prediction of skill deposition. So I'm sure as petroleum engineers we have an idea of what skill deposition is. So this talk should be clear enough. Yeah. So during oil and gas production, we experience skill deposition is a flow assurance problem. Skill gets deposited in the pipes, in the separation tanks and other facilities, and it hinders flow, it causes problem, it reduces the production volume, and it can be severe in some cases. You have to like take out the pipe. There are ways to control skill. We use inhibitors, we use mechanical methods, and there are so many methods of controlling skill. But the reason I saw a need for this research was this: the existing methods of skill prediction make their predictions by detecting the presence of skill after its deposition in production facilities. So after the skill is already there, that's when you can use the software is available to detect it. But that's also expensive because what happens when it's already there? You now have to like think of ways. Do you need to shut down this production system to handle it if it's in a severe case? So this downtime can like reduce our income. And just like Brain said, in the energy industry, time is money. So I for skill to be effective and less expensive, accurate prediction of scaling immediately deposition commences is important. So that was the need I saw. And then in my thesis, I built a machine learning model that predicts the deposition of skill in of all types of oil field skill. So this model predicts the deposition immediately it starts. So once the conditions are tending towards skill precipitation, the system detects it, the model detects it, and you can be alerted. Yeah. So let me tell you how I went about it. The data sets, I had to do research to see what type of data. Already scale control is something that is an area that has been researched into a lot in the oil industry. So it wasn't hard to know the type of data I needed to use to predict it. So from my research, I saw that I needed information about the pressure and temperature of the oil facility. I also needed information about the chemical concentrations and the different ions present in the water sample. Now, if we know about scale is precipitated from the water that is being produced from the well. So um we needed to I needed to take data from water samples, and this I got this data through a secondary source actually. I didn't go to the field and record the data myself, but I got it from other people's research. So I sourced for data from a research that was done in the Niger Delta and another research done in the Danish sector of the North Sea. I took data samples from that was recorded from water samples. I took from temperature and pressure. If you let me read some of the parameters I used. So there was temperature, pressure, CO2 mole fraction, pH, calcium ion, sodium ion, magnesium ion, and so many other things. We also recorded the scale type and the inspection result. That's because as the data was recorded, the result of the inspection was shown. Either scale was formed in that well or no scale. So the programming language I used to develop my model was Python. So I had a lot of us requesting to find out what type of language we should use. So recent research shows that a lot of majority of data scientists use Python. And yes, that's because of there's a lot of open source libraries and tools available for your development. But it's not just restricted to that. You can use R. I know a lot of people that do statistical research use R. You can use Java and so many other languages. But I used Python for this particular research. The machine learning problem type. So when Brain was talking, he told us about the different types of problems we experience. So this was a supervised classification problem. What made it supervised was the fact that we already had the inspection results. So when you say it's supervised, there's the type of outcome you need, and then you have data that will give you that type of outcome. So in this case, since we had the inspection results recorded, it was a supervised problem, and then it was a classification problem because we needed to classify. I needed to classify the results as either skill or no skill. Now, in the research, I experimented with three algorithms. I experimented with support vector classification algorithm, logistic regression algorithm. I experimented with also decision tree classification algorithm. And after building the models, I've evaluated them. And then the decision tree classification algorithm performed better. So I went with it as my model. And then for evaluation, so when you hear about model evaluation, of course, when you build models, you can't just be sure if they will do what you want if you can't evaluate their performance. So the way it works in machine learning, you have to set aside some data for testing. So you use some data to train your model. Majority of your data, you use it to train your model, but then you set some percentage of it, maybe like 20%, 30%, depending on how much data you have. You set it aside for testing your model to see if it actually performs how you want. There are different types of metrics to evaluate models, depending on what you're hoping to achieve. Sometimes the accuracy of the model, that's in the total population of your data, how much of it is correct and how much is not correct might be enough. But in this situation, I use the receiver operating curve, that's the ROC, and the area under the receiver operating curve, AUC, evaluation metrics. Now, this ROC curve, it's like a plot of the true positive against the true positive rate against the false positive rate. Okay, don't get alarmed about the terms I'm using, but let me put it in the simplest terms, since I believe some of us here are beginners. So the true positive rate is like how many of the predictions that the model says are true are actually true. So true in this case being skill, and then false being no skill. So for false positive rates is like how many of the no skill incidences the model predicts are actually no skill. So why I chose this was because of this. Now, in the oil and gas industry, a small mistake can cost billions, right? We wouldn't want our model to classify a scale problem as a no scale problem, because then the scale would deposit and we would have ignored it and not put any measures in place, and that will now bring future expense. Same thing goes for no scale incidences. Let's say the model predicts a situation that is not scale formation as scale formation. That means we waste our inhibitors in a situation when we could have economized it and kept it. So that was why I found this particular evaluation metric useful. So in machine learning, as you go into learning AI, what I'll advise you is to have a very good understanding of the different evaluation metrics, so that you don't build a model and think that it's perfect, and then when you try to use it in a real life scenario, it doesn't work because you chose the wrong evaluation metrics. So let me go to the results. This is just a summary of what I did. I'm working to publish the whole research work as a journal paper. So yeah, the results after evaluating the model I went with, which was the decision tree model, had a performance score of 91%. This is the AUC score. The area under the curve was 91%. So that means 91% of the time, what the model predicts is actually what it is. So this was good because it was my thesis, yeah, my final year project. So I worked with this, but in a real life scenario, I think I would go for a higher performance score, maybe something above 95. Yeah. So that I'm also furthering this research. So I'll get more data and work more on my model and increase the performance. But above 90 is good. Above 90 is good. For this, you can see the table on the left. Yeah, the table on the left. So one representing skill and no skill is zero. Your computer understands zeros and ones. It doesn't understand um no words. Even when you do natural language processing, which is like understanding words. This computer still has to interpret it in a binary form. The real language the computer speaks is binary. Yeah, so the data set I got, the results were represented with skill and no skill, but I had to manipulate the data. That's part of data science. You have to be able to like wrangle your data and put it in a form that your computer can understand. So I converted the skills to one and no skill to zero. So in this table now, I didn't just generate this. I didn't just sit down and type out this table. This was actually what the model predicted. So inspection results is what the original data set had. That's for my test set. Remember, I told you I kept some data aside. Yeah, so for the test set, these were results of 10 samples, 10 randomly picked samples. And then I let the computer predict, which is the decision tree model prediction on the right column. And you can see that all the answers are corresponding. That means the model actually correctly predicted it. So these are zeros and ones. But when you're making it available for the end user, you have to make it in a way that it will be understandable to the person. So you have to also translate it back to scale and no scale when you're like deploying for an end user. So yeah, the graph you can see on the right side, it's a cross plot I made with the research. I think this research work was in the departmental library, University of Port Harcourt. Yes, in the Petroleum Department Library in the University of Port Harcourt. So it was a research done by one of our former students, Engineer Chike Wonodi, in 1999. So he also tried to predict scale deposition. He used the scaling index, which I'm sure most of us, that's what was very common. I think even the scale software, which is the common software used in the industry for predicting scale, it uses the scaling index method to predict scale. In his method, scale was the scaling index. If it's negative, he said it was no scale, and if it's positive, he said it's scale. So while in my own method, I put scale as 1 and no scale as 0. So that's why you see that some values are at the bottom. Those values that are on the x-axis or the horizontal axis are zeros to me, like to the decision tree model. They are the zeros, while the ones that are at the top at where 1 is, those are my skill. But at the same time, you can see that most of the things I predicted as no skill are also negative to the one or the model, except for one value. And then most of the things I predicted as skill are also positive. You can see them at the top here. They're on the positive side of the axis. So for this single value here that you see is positive, and my model put it at the bottom, that was a a prediction from one of these model. Now, yeah, so after I did the prediction and I looked at the data sets, I saw this particular one. I went back to the observed results. Remember, I told you that the data set had observations of the inspection results. So the decision tree model was actually correct for predicting it as no scale, and the scaling index was wrong for predicting it as a positive scaling index, which means scale. So you can see that the decision tree model actually performed better than the scaling index method from this graph. Yeah, so you can use this graph to correlate. Maybe you have scaling index and you want to see what the decision tree model will classify it as. You can use this graph to correlate it. So to make the output of this model available for end users, the model will be deployed either as an API that can be plugged in easily to existing software systems, or as a standalone application. So after building ML models, after building your ML models, one next, right, is just a model to you. It's not yet serving any purpose to anyone else except you. So you have to deploy it. There are different ways of deploying machine learning systems, machine learning models. You may want to use it in applications like Siri or Netflix, Google search. So you may need to make it available to users through applications. You may need to build a separate software of its own, like this software now will give it a name. For instance, this model I've built now, let's say I want to make it I want to have my own software for predicting scaling that people in the oil and gas industry can use. I can make it available through a separate software, or I can decide to make it something, an API that you can integrate. An API is application programming interface. So it's like a code that you can integrate to already existing systems, and then the whatever is being implemented in your model will be available to them. So those are ways you can deploy the information here. So if you learn AI and you want to, yeah, someone also asked, they want to know how they can learn it and monetize it. So yes, this is how you can learn it and monetize it. You can develop, see a problem in the industry, see a problem outside the industry, a problem in your environment, develop a model that solves that problem, make it into an API, and then market it to the people that need it and make your money off it. You can also make your own application. Of course, you need to work with, if you don't know how to develop maybe mobile applications or web applications, you may need to work with another developer that knows how to develop that and then make it available to people. I made some links available. So these are all links to different projects. So this one is machine learning techniques characterizes source rock images at pore scale. So you can see this as an application to reservoir engineering. So in fact, you don't even have to do the calculation of bulk, volume, and pore size, and just think about, oh, are the pores connected or not? Your machine learning model can characterize it for you. Like, it can actually predict, maybe based on the seismic data you get, it can predict what's the pore volume, how much of the volume is connected, and give you a better understanding of your reserve. Computer vision, the second one we have here, we say computer vision analytics enables determination of rig states. So this is in rig monitoring. Like, you have to like monitor how things are happening, how the people are working, if they are being safe, if anything is going wrong, to avoid the worst case scenario. Computer vision can be your guy. At least it can help the HSC personnel determine how things are happening, are people being safe, and is anyone in danger at the moment, things like that. So we have under one, artificial intelligence and machine learning technique for corrosion mapping. So you see, it's not just scale deposition. You can use it for even knowing how corrosion is eating up the pipes you have on your rig and the rest. So it's also helping with digital data acquisition. So you hear about computer vision, like literally you're using what are the stuff, drones. You're using drones to like monitor the environment, record those videos and pictures, and turn them into data, turn them from just being mere pictures and videos that the computer can interpret. With artificial intelligence, the computer can now interpret those data as things that can be used to gain insights. So yes, we're getting better digital data acquisition with the help of AI. So there are so many more. I put not just applications in the oil and gas industry, also outside the oil and gas. Yeah, so they say AI predicts new materials for clean energy. So you see, even in the energy transition, AI can be our guy. It can give us like better insights. We're not just transitioning blindly, but we can actually get the help of AI to make these decisions. So wherever there's a need for decision making, AI can be of help. AI can assist not just the technical processes in petroleum engineering, but even the economic processes. So think about where natural language processing can actually work on your past records of financial records and company policies, and then improve on it. So you see that there's a lot of potential. So the aim of my presentation was to leave you people with like ideas of how you can apply it in your area of interest. Because to me, I feel it's easier for you to learn a new skill, no matter how difficult it seems. It's easier to learn it when you have an idea you want to implement at the end. For instance, if you dream and say, oh, if I learn this I can actually solve this problem that was being experienced at my workplace. That's a drive. That gives you a reason to like spend 2 hours every day on learning AI. And that's something. This is 2022 statistics. US and global artificial intelligence in healthcare market size will surpass 95 billion USD at 46.1% CAGR growth. So you can see that the market for AI is growing. 95 billion is not small money. Okay, there's one about a startup. So Tunisian AI startup Insta deep raises 100 million. So people are building small companies with AI and they are raising big money. 100 million for a startup is not a small investment to raise. So this last one is a paper I presented last year at the SP NICE conference. So this is on applications of AI and data-driven modeling in energy and marketing, energy production and marketing processes. So I think you can look at all these links and read about them. They are all links, so you can read about what's really happening and see. It can give you ideas, actually pick up your interest, not just let's not just be theoretical interest. I want to learn AI, but you can actually see it in a practical sense. So my question, I'm leaving with this question. I said, are you an energy professional asking yourself is if acquiring a skill in AI/data science is a good decision? My answer is yes, it is. It is. It will help you in your career in petroleum engineering. It will help you if you decide to switch careers. AI has come to stay, and it's something that you won't regret learning. It's not something that you'll be afraid that in a few years, oh, my skill will not be needed again. Learn it and you can apply it in so many ways. All you just have to do is imagine.